All right, welcome back. So now that we've talked about Simulink and we know what it is, we know what the library browser is, and we know where to get some of the components that we're going to need from, let's actually go ahead and build a model now. And we're going to start by building a somewhat simple electrical circuit as an example, but of course that's going to just be an introduction. We can also build more complex models once we know how to build a simple model. So we're going to start with a very simple electrical circuit, and then we're going to move on to more complex circuits or more complex models. So what I want to build is essentially a circuit that has a resistor, a capacitor, and a controllable voltage source. And the reason why I want a controllable voltage source is because that's going to be a little bit more complex than just having a regular voltage source. And we're going to need some generic operations blocks for using that block. So let's see what I mean by that. Let's go to the library browser, and from here I'm going to get several blocks, and I'm going to explain here in a second what each one of them is going to do. So first thing that I want is, again, I want a capacitor and a resistor. So I can go here to electrical elements, and I have my capacitor over here. You can right click and hit add block to model untitled. So right click, add block to model untitled. And I'm actually also going to need an electrical reference. So let's go ahead and add this one. And I'm going to need a resistor as well. Again, for searching for components, if you know what you want, you can also do a search here in the search bar. So let me type resistor over here and do a search, and it comes up over here. So I have my resistor now, and I also want a controllable voltage source. So that would be, of course, under electrical sources, and I want this one, a controlled voltage source. And let me add that to the model. Now, if we go back into our model, you can see that all of the components are dropped here in the middle. So let me go ahead and move stuff around. Let me move this over here, and I'm going to rotate these blocks so that they're vertical instead of horizontal. So what you can do is you can click on it and then do Control R, and that's going to rotate the block. Or you can simply just right click and go here to where it says rotate and flip, and you can flip it clockwise, for example. And let's do the same thing for this one. Again, you can just click on it and hit Control R, and that's going to rotate the block. So to connect the blocks, you can simply just click and drag here the connections, and that's going to bring, for the case of an electrical circuit, that's going to bring a wire between those two components or those two blocks in the model. Now, usually you might want to align components within your model. So you can see that I move over here the voltage source, and as I move it, Simulink knows that I'm trying to sort of align that with the capacitor and the resistor. So you can see the lines that come up over here when I drag this. So that tells me, okay, these are equally spaced between each other. That's always a good practice, just to keep your models a little bit organized, especially when you have very complex models. You certainly are going to want to keep things organized just so that it's easier to follow the model. All right, so same thing. I can connect here the positive polarity and the negative polarity over here to my circuit, and of course I'm going to need my voltage reference. Now this is a controlled voltage source, and what that means is that we have an external input to the voltage source that tells the voltage source what the voltage should be. Now each block is going to have a parameter. So what's called a parameter is basically just how we define the blocks. For example, this capacitor, of course, is going to have a capacitance value. So you can see here that it has a capacitance, series resistance, parallel conductance. So I want a capacitance value of 1 millifarad. So I can do that in two ways. I can either say 1 e to the minus 3 farads. That's going to be, of course, 1 millifarad. Or I can change the units over here on the right. I can say, well, I want this in millifarads, and I can change this simply to just a 1. So that would be 1 millifarad. Now, you can also define variables over here if you wanted to measure the current and the voltage for the capacitor. but I'm going to show you later on how to do external measurements instead of using these internal measurements for the block. All right, so I'm going to click OK over here, and let's also define this resistor. I want a 10 ohm resistor, so 10, and then again units over here on the right, 10 ohms. And that's it for the capacitor and the resistor. Now the same thing applies for the voltage source. Those are going to have parameters. However, because this one is a controlled voltage source, we don't need to define the voltage over here. Instead, we have this external input that defines what the voltage output of that voltage source is. And again, if you're trying to get help for this block, you can click on it and go to help, and that's going to bring up the documentation for the controlled voltage source. So if we look at this one, it says the controlled voltage source block represents an ideal voltage source that is powerful enough to maintain the specified voltage at its output regardless of the current flowing through the source. The output voltage is V equals Vs, where Vs is the numerical value presented at the physical signal port, which is this third port over here. Now notice what they're saying here at the physical port. That's going to be important, as we're going to see here in just a second. So let me go back to my model. And what I want to do here is I want to define that input such that the voltage of the voltage source is a scaled version of the simulation time. So let's see what I mean by that. Let me first add the blocks that I'm going to need. I'm going to need what's called a clock. So I can do a search for that and do a search here. I'm going to add this to the model, and I'm going to need a gain as well. So let me do a search for this gain, and let's add this to the model. All right, so now I have a gain and a clock. Now again, you might or might not know what this means. So if you don't know what something does, you can go to the help menu, and again, that's going to bring up the documentation for that specific block. So for example, for this one, it says the clock block outputs the current simulation time at each simulation step. This block is useful for other blocks that need the simulation time. So basically what that's saying is, if I'm running my simulation, let's say from 0 to 10 seconds, again, remember that this time over here means how long is Simulink going to run the simulation as if it were in real life. So it's going to go from 0 seconds, 1 second, 2 seconds, 3 seconds, 4, 5, 6, all the way to 10 if we leave this at 10. So what this clock does is it outputs a number that's equal to the time of the simulation. So as the simulation runs from 0 to 10 for 10 seconds, this clock is going to output the exact time of the simulation time. In other words, if we're at time equals 1 of the simulation time, so a time equals 1 second of the simulation time, the clock is going to output a 1. If we keep running the simulation and we're at the simulation time of 5 seconds, then the output of the clock is going to be 5. So that's what this means. And again, remember that this number is the simulation time in seconds. It's not related to how long it takes to run the simulation. Rather, what it is Simulink runs 10 seconds worth of simulation as if this circuit was in real life. So hopefully that makes sense. It's going to make a little bit more sense once we actually run the simulation. So what I want to do is I want to use this block and I'm going to scale it by 5. So essentially, when we're at t equals 0 for the simulation, the output of this block is also going to be a 0. When we're at t equals 1, the output of the clock, so this point over here, is going to be a 1. Then we're going to scale that by 5 such that the output of this block is going to be 5. So the output essentially is going to be 5 times whatever the simulation time is. Now I want to feed this into this block, but notice that it's not letting me do that. Notice over here, and let me actually zoom in a little bit. Notice that I cannot connect this block to this input over here. And that's because remember that when I went over here for the clock help, or rather the documentation for the clock, notice that it says the output, and that's probably somewhere around here, sample time. Or actually what I was looking for was the controlled voltage source. Yeah, over here. So notice that it says the output voltage V equals Vs, where Vs is the numerical value presented at the physical signal port, which is this third port over here. So Simulink has two different types of signals. Signals that are called a physical signal and signals that are called a Simulink signal. That's important because there are different types of signals, and Simulink won't let you connect blocks that have different types of signals. So things like circuits, for example, or mechanical components, or anything that we saw in the Simscape tree. And let me actually go back to the library browser. So all of these, for example, so if we go to gas, all of these blocks are what's called a physical signal, because of course they represent physical signals in real life. So a capacitor, if it were in real life, it would be an actual physical thing. Now there's also Simulink signals, which are just generic operations. Those are different, and actually notice that the colors are different. These are black, while the physical signals are actually in color. And there are a little bit different colors for different domains. So the magnetic, or rather the mechanical, are these colors, and then electrical are different color. But again, notice here that the generic operations are all black. So those again are called Simulink signals, while the actual components, the physical components, so like sensors, sources, and elements, whether that's electrical, magnetic, or mechanical, or hydraulic, or whatever, those are called physical signals, not Simulink signals, as are these generic operators. That's important because again, Simulink will not let you connect those two blocks without having a converter first. So let me show you what that is. Here back at the model again, notice that this is black and this looks like maybe a bluish color. But again, notice that I can't connect this to this. That's because the output of these blocks, these ones over here, are Simulink signals, and these blocks are physical signals, so you cannot mix the two. However, there's a block in Simulink which is called a Simulink to physical signal converter. So let me do a search here for converter, and we're gonna see two blocks over here. This one over here and this one over here. So this one converts from physical, or rather from Simulink to a physical signal, and this one converts from a physical signal to a Simulink signal. So what I want here, again going back to my model, is to convert this signal, which is a Simulink signal, into a physical signal such that I can input that into this controlled voltage source. So I want a Simulink to physical signal conversion. So this block over here. And again, the reason why we need this is because generic operators and physical operators are two separate domains in Simulink. So you need to have a converter from one domain to the other. All right, so I added this converter over here. Now I can connect it over here to the gain block, and now I'm able to connect that to the controlled voltage source. So again, the model that we've built over here is simply just a simple electrical circuit. We have one capacitor, one resistor, a controlled voltage source, and the voltage of that voltage source is going to be controlled by this control signal over here, which is simply a scaled version of the simulation time. So at t equals 0 on the simulation time, the input to this control voltage source is going to be 0, so the output voltage is going to be also 0. At t equals 1 of the simulation time, the output of this clock is going to be a 1. Then we'll scale that by 5. That's going to be a 5. We convert it to a physical signal, so we input that here to this control voltage source, which means that the output of this voltage source is going to be 5 volts, and so on and so forth. All right, so next let's take a look at how we can manage some of these signals, how we can run simulations, and how we can take measurements to see the performance of our